right, ladies and gentlemen, let's talk about scientific notation operation rules. Okay, guys, if you remember your laws of exponents, which I'm also going to include in your message, the laws of exponents also apply with scientific notation because we're dealing with exponents. Okay, all right. The one, guys, that's the hardest, in my opinion, is addition and subtraction, because the rules are very specific with addition and subtraction for scientific notation. All right. The only time that you can add together two scientific notation problems is when the powers are the same. The only time that you can subtract two scientific notation problems is when the powers are the same. So when I look at these two scientific notation problems, 1.02 times 10 to the fourth and 1.69 times 10 to the fourth, I can add them together the way that they are because they're both to the fourth power. So I'm just going to bring down my times sign and my 10 to the fourth power because we're going to keep these the same. And the only thing that I'm going to do is add the bases together. So 9 plus 2 is 11, 6 plus 1 is 7. Bring down my decimal, and 1 plus 1 is 2. Then I'm going to check my answer, 2.71 times 10 to the fourth power. This isn't scientific notation because my number that's in the front is greater than or equal to 1. And it is also less than 10. So my answer should be 2.1 times 10 to the fourth power. Okay, let's look at this example over here of adding two scientific notation problems together. All right, 5 times 10 to the 6th plus 7 times 10 to the 6th. They're both 10 to the 6th power, so we're safe. So I'm just going to stack these on top of each other so I can add them. I'm going to keep my times 10 to the 6th power. The exponents won't change. And I'm going to add together 5 and 7 to get 12. When I check my answer, 12 times 10 to the 6th power. This is not in scientific notation. The base is too big. So what we need to do is change our base. I need to make 12 smaller. So that means I have to make the 6th power bigger. So the natural decimal point in 12 falls right here. If I move it, it'll be 1.2. That's greater than or equal to 1, but less than 10. And like I said, we make 12 into 1.2. That's smaller, so let's make 10 to the 6th power bigger. What's 1 bigger than 6? 7. There's your answer, 1.2 times 10 to the 7th power. All right, here's another one, guys. We've got 5 times 10 to the 3rd minus 5 times 10. Okay, I'm going to stack them on top of each other. Helps me kind of keep things straight. Cannot subtract these the way that they are, guys, because the exponents aren't the same. This exponent is to the 3rd power. What's this exponent for 10? It's 1. So, guys, what you need to do when you don't have the same powers, you have to make your powers match. So, I either need to make 5 times 10 to the 3rd power smaller, or I can make 5 times 10 to the 1st power bigger. I'm going to choose to make this match this. So I'm going to take 5 times 10 to the 1st. And I know if I want to make my power bigger, then I have to make my base smaller. So how many do I need to make 3? I need to move my decimal point twice. How do I make 5 smaller? By moving my decimal point to the left. Once, twice. What do I fill in for blank spaces? Zeros. Okay. So what I'm really doing, guys, is just trying to make these match so that we can complete the operation. Since I moved it twice, I'm going to add the 2 spaces to this 1 to make 3. So my answer should be 0.05 times 10 to the 3rd power. So I'm just going to make the changes in here. 0.05 times 10 to the 3rd power. And now I can subtract. So what's 5/100 minus 5? 5.00 minus 0.05. 4.55 times 10 to the 3rd power. Okay, guys, let's look at one more like that where the powers aren't the same. So we need to change it. Okay, we're adding 3 times 10 to the 6th plus 4 times 10 to the 5th. So these don't match. We need to make them match. I think it's much easier for us to turn 5 into 6 than trying to turn 6 into 5. So I'm going to take my 4 times 10 to the 5th power. And if I want to make this bigger, that means I have to make my 4 smaller. Natural decimal point in 4 is right there. To make it smaller, I need to move my decimal to the left. Just one space, because I just need 1 to make this a 6. So it'll be 0.4. And then I'll add my 5 plus 1 more to make 6. Okay? So now I can make those changes in here. This is 0.4. And this is to the 6th power. Keep your bases the same, so that's times 10 to the 6th. And 3 plus 0.4 will be 3.4. And we're good because this decimal is greater than 1 but less than 10. Let's look at how to multiply, guys, and divide. This is easy. All right. 7 times 10 to the 4th power times 2 times 10 to the 6th power. All you have to do when you're multiplying scientific notation together is just multiply the bases. And if you remember your laws of exponents, this is power of a product. You're going to take these together and add them. So let's do that. 7 times 2 is 14. And when you add the powers, 10 to the 4th and 10 to the 4th and 10 to the 6th is 10 to the 10th. Is this in scientific notation? No, it's not. We need to move the decimal. How can I make 14 smaller? By moving it one place to the left. And if you make it smaller, you have to make your power what? Bigger. How many bigger? How many times did we move the decimal? 1 bigger. So our answer should be 1.4 times 10 to the 11th. Here's another one. 1 times 10 to the negative 1st power and 3 times 10. Let's put some exponents in here. This is a negative 1. What's this exponent? 1, right? Let's multiply. 1 times 3 is 4. And what are we supposed to do to these powers? Add them. What's negative 1 plus 1? 0. What's any number to the 0 power? Laws of exponents. This is 1. So what it's really saying is 4 times 1, which is 4. So you can't really write 4 in scientific notation. So guys, you may come across a problem like this. I wanted to make sure I showed you something like that. Here's another similar one. You have 6 times 10 to the 0 power and 6 times 10. So this 10 is to the 1st. You could do it one of two ways. You can recognize that this is raised to the 0 power and say this is just 6 times anything to the 0 power is 1. And this is 6 times 10. 6 times 1 is 6. And 6 times 10 is 60. So that's actually 120. Now, if you want to write that in scientific notation, you could. How many times have we moved the decimal? Twice. So it's 1.2 times 10 to the 2nd power. Positive 2, because this number is greater than 1. Division. When you're dividing two scientific notation problems together, you just divide the bases. And if you remember power of a quotient, what do you do to these exponents? You subtract them. So when we divide, 6 divided by 2 is 3. And we're going to take these two powers and subtract them. 5 minus 2 is 3. 3 times 10 to the 3rd power. That's scientific notation. It's greater than 1 but less than 10. Here's another one. 1.4 times 10 to the 7th divided by 2 times 10 to the 6th. We're going to divide these and subtract these. 1.4 divided by 2 will give me 0.7. And 10 to the 7th divided by 10 to the 6th, I'm going to subtract the two exponents to get 10 to the 1st. Is this in scientific notation? It is not. We need to move the decimal point to make this bigger. So we move the decimal point one place to the right to make this bigger. And when you make this bigger, what do you have to do to your power? You have to make this smaller. So if I make this 1 smaller, this is 10 to the 0 power. And this should be 1. So this should equal 7. Look at that. You may see something like that, guys. I know I went through that kind of fast, guys, but if you have any questions about scientific notation or their operations, just let me know. Thanks, guys.